Good morning, everyone. How are you? I am definitely not tired. I would just hold my eyes open like this all through the lesson just to make sure that I can prove that I'm not tired. My eyes are definitely open. I think I was only up twice last night, like 2:30 and 5, something like that. But yeah, it's been an interesting couple of weeks. But I wouldn't change it for the world. I love my daughter. She is amazing. I love my wife. She is amazing. So let's learn some maths. Now, a little bit of an apology. We haven't got our studio today. We're going to be working on the whiteboard. This is because sleep things happened and took over, so I meant to be up a bit earlier. But it's no problem. We've still got a starter, so we're going to go straight into that after I've done the introduction. So we're going to talk about converting decimals into different formats. Okay, for me to do a proper introduction, I guess I need a starter, so don't worry, I've prepared one. Here's one what I prepared earlier. We've got an anagramma starter today. In the anagramma starter, you have to write down from those 9 letters, CRETODVEN, as many words of 4 or more letters as you can. I probably need to move that over slightly because I'm covering up the V. So let's put that there, and hopefully you can see that better now. So CRETODVEN, as many words of 4 or more letters. Just list them down on a page. You don't need to put them in the chat, or just see how many you can come up with in a minute while I say good morning to Josh and Sophie. Good morning, Iona. Good morning, Poonam. Good morning, Alicia. Good morning to Nathan. Good morning to Charlie. And good morning to Alvi and Iona. Good morning to Rubik Cuba. I forget who you are. I do apologise. Good morning, Debbie. Good morning, Adeline. Good morning, Harry. Good morning, Donny, Stanley. Good morning to anyone else who's here. To be honest, good morning everyone who's joined us today in the chat. I hope you're coming up with lots of words. Well done, Josh, for coming up with the really long one. Harry, do try and find someone like 4 letters if you can. There are really good 3-letter words. That's absolutely fine, and especially if you're a year 3 or 4, that's absolutely fine coming out with 3-letter words. But push yourself on 4-letter words today. I'm going to go the word that I'm going to use as the bonus. You get 2 points if you got this word. Is code, because I love codes. I love puzzles and codes. So code, CODE. So there's also some longer ones. So you may have spotted in the chat that Josh or Sophie, I don't know which one it was, got converted, and that's because that's what we're talking about today. But you can also there's a rat present because rodent is also there. Rodent is there for 6, and vector. Anyone who's followed any of my GCSE stuff will know that vector is something you learn about later in your maths, about how you move things around using vectors. So that's quite another good 6-letter word. So well done everyone who took part in that. If you want to pause and see how many you can come up with, I would love to see after the event people putting something in the chat, showing not in the chat, in the comments below, all the words they came up with. See if you can set each other challenges. See if you can be the person who leaves the comment with the most words coming out of these letters, the 4 or more letters. And then if someone tries to gets 20, see if you can get 25. And if someone gets 25, see if you can be the person who gets 30. Have an ongoing challenge in this video for who can get the most words. Put them in the bottom after the video is finished. So, we now need to move on. What are we going to do? Well, we need to turn decimals into things. Decimals always start in this format. 0.241 or 1.27 or 19.6. As long as they've got a decimal and then some numbers after it, it's a decimal number. And we're going to be talking today about converting them into 2 different things. We're going to convert them into, first of all, into fractions, and second, into percentages. And today, as I did warn you, for the next few weeks, the worksheet, I haven't got a worksheet for you today, but I have left in the link to the description, I have left a link to the Corbett Maths 5 a day, so you can practice things that are all for the right level. So hopefully that you'll be able to see that and try different things on there. So that might be useful for you. So let's go straight into how would we convert a simple one. Let's rub out these complicated decimals. They're not that complicated, but let's rub these out for a second and work with simple decimals. How are we going to work with 0.7? Well, in order to work this out, as well as hundreds, tens, and units, we need to think of decimals as having hundreds, tens, units, tenths, hundredths, and thousandths, etc. You can add a naught and keep going on. So when you look at this, you write above it hundreds, tens, units, tenths. And you say, well, in that case, I've got 7 tenths. So 0.7 must equal 7 tenths. It's not, some people put 1/7. Hopefully you can see, because of, this is all because in maths, we use a system called a decimal system. A decimal system is not what they used to use. In the Roman times, they used to have a hexadecimal system, which was a base 60. This is the reason for two things you use in life without even thinking about it. Minutes, seconds, are both in 60s, and hours are 24, which also is a number that fits nicely into 60s. It's because we've still got those systems because of the time when we used to have a hexadecimal system. Base 60. So now it was converted to a decimal system, which is base 10, which means every time we get to 10, we change up to a new level. This is why we can do this with other numbers. So let me do this one, 0.19. Well, using this hundreds, tens, units, tenths, let's go through. We've got 0 units, 1/10, and 9 hundredths. The way we do this is we don't put 1/10. We look at the final number is hundredths. So we're going to say we've got 19 hundredths. That's how we're going to convert that decimal from 0.19 into I'm in the way, sorry. I said to myself as I was doing it, I must remember to switch back. Thank you for letting me know, really helpful. So we've got the 0.7 goes 0 and then the 7, and then that's why it's 7 tenths, because the 7 is underneath the tenths. 0.19 is under the tenths and the hundredths, so it's 19 over 100. We can keep going, but I want to rub out the ones we've done so far so it's not confusing there. We'll do 2 more under here, and then I'll set some as challenges for you to do. So, what about 0.174 and 0.4? So, feel free to pause the video if you want to, so you can have a go at this before I show you. That's allowed. Feel free, if you're doing it live, just to write down what you think the answers are. I'm giving you a bit of waffle while I talk to you and maybe have a sip of my coffee. Clearly, Mrs. Fronsdorf Harris, which is my wife, thinks that I'm a Hufflepuff today, which is good. Beautiful and creative. I don't feel beautiful and creative. I feel tired and sleepy. So, we've got 0.174. It looks to me like the 4 is in the thousands, and so we get 174 over 100. But wait. There is one more step if we can cancel at all. Because I noticed that 4 makes it an even number. So I've got both of these numbers divided by 2. So I'm going to have to divide them both by 2. So I'm going to write divide by 2 and divide by 2 just to show myself what I did. And this leaves that as, well, 80 divided by 2 is 90. And this is 3 less, so this must be 87. 87 over 500. And 87, I just had a quick check, is not in the same times table as anything in the 500s. 500 has got 5 in it and 2 in it, and lots of 5s and lots of 2s. But so 87 doesn't have 2s or 5s in it. So this would be the completed. We would call this the simplest form. And when you're converting decimals into fractions, you should always try and leave it in its simplest form. we will now do 0.4, which would probably be the better one for me to have done first. But being Mr. Harris, I don't follow normal conventions. 4 under the 1/10 gives us 4/10, which divides by 2. So I'm going to write divide by 2 is 2/5. Here we get. You can see the answer we're looking for is dependent on how much you want to be accurate. I hate the phrase "the answer" because this is not anything other than what we're trying to do. So because we're trying to turn a decimal into a fraction, you could call it the answer, but just call it the fraction form, because it's very important to me, but also to facts. You realise that 0.4 is equal to 2/5. They are still the same amount. If one person said, I'm going to give you 0.4 of my fortune, and someone said, I'm going to give you 2/5, they're giving you the same amount. So don't ever lose sight of the fact that that is the same quantity. 0.4 is the same quantity as 2/5. They're just different forms. In the same idea as Mr. Harris is in this form right now. Look, this is Mr. Harris in Mr. Harris form. If you ever watch Numberside, he transforms into all sorts of different forms. But at night, I transform into Batman. I shouldn't tell people my secret identity. I'm going to get in trouble now with my butler. But I'm Batman. I'm Batman. So let's go back to the screen. You can tell I'm a bit sleep deprived, can't you? So this is decimals into fractions, which is the first thing I said I was going to do. We also have decimals into percentages, which I think are a little bit easier. I'm going to list 4 we're going to do. We're going to do 0.41, 0.09, 0.24, and 0.7. And I'm going to make that look a bit neater so that people can see that's a 4 and not some sort of weird squiggle. So we've got 0.41, 0.09, 0.24 and 0.7. To turn them into percentages, here is my system. I can still write hundreds, tens, units and tenths. Not that that's a half, isn't it, Mr. Harris? That's not a tenth. Tenths and hundredths. But the reason we do it this time is because this is where we're going to stop. Even if there's more numbers, and we might use them to round, and we'll do an example of those in a minute, but because percent means out of 100, percentages, per means out of, cent means 100, ages because it takes ages to learn how to do them. Mr. Harris, really need to grow up. Okay, so in order to turn these into percentages, it's just a case of look at the first 2, 4 and 1, so that's 41%. 41 out of 100. Remember, we've already worked out from what we'd learned earlier that would be 41 out of 100, and that's how we know it's going to be 41%. The next one, well, 0.9 is we just write as 9 out of 100. We don't bother writing the naught, so it's 9%. Remember that 0, we still have to include it as 0.9, so it's 9%, not 90. 2/4 is 24 over 100, so it'd be 24%. I'm just checking I'm showing everyone. Don't worry, if anyone's spamming, Alicia will sort it out, and I'll try and make sure. So thank you for letting me know, Patrick. Charlie doesn't understand. Charlie, where's your question, Charlie? I'm just scanning for it. I do apologise. Can I see where Charlie was stuck? Charlie, could you rewrite your question, please? Because I'd like to make sure I help you, but I have allowed it to go too far. Alicia, if you're able to answer questions, do feel free to do so in the chat, and I might choose someone else to do to try and help. Charlie, where's Charlie's question? I can't find it. Someone said Charlie's stuck, but I can't see where. It will be under Jules. I don't understand all of it is not going to be a helpful question, I'm afraid, Charlie. You can rewatch the video. What you need to do is tell me, the minute someone gets go, you have to say, how, this is what I try and use in a lot of my videos, how why, or what questions. So if I write something like 41 over 100 is 41%, so 0.41, I looked at the first two decimals, and it was 41%. If you don't understand that, what you do is you say, so, Mr. Harris, how did you get 41%? Because I can answer that question. What I can't answer is, I don't understand. Because there's nothing for me to say. I could just go, oh, okay. You have to try and turn it into a good question. But that's a learning thing as well. So if you've not learned to write good questions, then that's what you're going to take away from today as well. So not a problem at all. It's okay to re-watch videos, rewind videos, go back and see what's going on. That's absolutely fine. Now this one's a bit tricksy. Because this 7 is in the tenths column. But we're talking about percentages here. So when we're doing percentages, we need hundredths. Percent means out of 100. Out of 100. So therefore, we're going to write 7 O out of 100. What I use is an extra 0. Because in decimals, there's zeros for the rest of the numbers. We just don't normally use them. But when we're turning into percentages, we want 7 and 0 makes 70%. So this one would be 70%. Hopefully that makes sense to people. We have to always have two decimals to make it into a percentage. I'm going to give you some to do yourself in a second, and then I'll put some answers up. But before I do that, there's one more I want to show you. I'm going to do that in red because it's like, what? What if it's 0.453? Sir, I've got too many digits. You told me, sir, that percentages need to be 2 decimals. It's got to be over 100 to be a percentage. Well, what we do is we just look at the first 2 because that's over 100. But the 3 now becomes a rounding number. If you get confused by rounding, I've done lessons on rounding and I will do more. So this 3 rounds it down to just 45%. There is an alternative. If you want to be even more accurate, you don't have to round it. You can write 45.3%. You are allowed decimals in your percentage, but your first 2 make the percentage, and any more would become a decimal part of the percentage. So you can have decimal percentages, or you can round it to 45%. If I was doing a test and was giving you your score back, I'd always round it to a whole number. If you were just trying to convert out and writing a report, and sometimes the report might be, has it gone up or down? You might want 45.3 might be different from 45.4. You need to still show that there's been a change. So you might need to show the whole decimal. That's more year 6, 7, 8. So I'm not going to spend too much time on that. It's just like an extra bit for people to see what's going on. What I am going to do is I did promise to give you some yourself. So these questions are yourself while I just check the chat for any questions, like Charlie was asking you questions. So we have got, could you please convert? Convert? Yes, convert. It's a new word. Could you convert 0.36? Could you also convert 0.8? Could you also convert 0.47? And could you also convert 0.726 into percentages, please? And I'm going to check if there's anyone chat. So lots of people doing the questions. Fantastic. Helping each other out. Adeline saying she understands. Brilliant. Why are you allowed for decimals in percentages but no in fractions? That's an excellent question, either Josh or Sophie. Why are you allowed decimals in... It's because percentages... how do I answer? Fractions are always a whole number over a whole number. That's what they are, because it's a division that you're going to do. In A-level maths, we would start having some decimals in there that then you convert out. You get rid of them when you can. But the reason is in fraction maths, you want whole numbers to make it simpler. So that's why they stick to whole numbers in fractions. Whereas decimals, it's the totality of the number. It's the difference. If you way back, I did a video probably about 6 weeks ago now on discrete and continuous. Fractions are discrete data, pretty much. They're countable. Whereas decimals are just like you can measure more and more accurately. So it's kind of to do with a similar idea. But it's a very lovely question, because in order to do that, you're exploring the math. Harry, what happens with 4 digits into a decimal? Well, let's do one of those when we've done these answers. So we've got some answers appearing in the chat. If you want to, you can pause it so you don't hear the answers yet if you're still doing them. we should have 36%, 2 digits. We need 2 digits, so we need a 0. Sorry if in the background you can hear, wah! Must be someone's feeding time, I think. It's not my wife, that's my baby, probably. Might be my wife. We never know which one's crying. I'll go and check on them in a minute. We've got 47%, and this one, we've got either I'll accept 73% or I'll accept 72.6%. And we did have an excellent question from someone saying, excellent, I love the fact that you said you get it a bit more now. That's fantastic. That shows that you're really trying to learn. I love all that. So, an excellent question, either Josh or Sophie. I would, if you want, you can always specify which one of you's asking. If I get 0.7115, then you've got two options. We could cut off here, just look at the 1, so it's 71%, or we can write 71.15. We can carry on the decimals and just keep making it, or you can round, and we could even, an acceptable answer here, I'd have to rub out this dotted line, you could even have an acceptable answer here as 71.1 would round to 71.2. That is it's still an acceptable answer because you've got the 5 rounding the 1 up to a 2, and then you've got 2 digits before the decimal. So 71.2 would even be an acceptable answer if you wanted just one decimal place. So all of those are excellent. Well done, Eddie, for getting lots of them right. What happens when you try and convert it back to the original fractional percentage? That is a lesson for next week, Nathan. I will be showing you how to convert it back. Feel free to have a play between now and then, but I didn't want to do the whole lesson where I taught you both directions because it might be a bit confusing. It is actually possible, just by watching this lesson, to teach yourself how to go back again. I'm interested to see if you can explore that, Harry, and be ready for next time. But, at the moment, what we've only done is turned decimals into other forms, rather than going backwards. What we will do another lesson is convert back to decimals from fractions, because there's a bit more to do if you're doing fractions. And remember, when we're converting to fractions, you always simplify your fraction. So hopefully you've learnt a lot today. Quick reminder, we've got an outstanding Taskmaster thing. The Taskmaster challenge for this week, I want more pictures sent to me on Facebook. I think you can also use the community section on YouTube. I've not used it much yet, so if you can reply to the community bit, reply to this week's, if there's a way of responding to the thing, or just email me, send me an email. I think on my screen right now you can see my email address, you can see the Facebook thing, if you can get your parents to go on Facebook. I want best pictures of a tray with as many I entries as possible. I've had a couple of entries already, so you've got someone to beat. I will show all the I entries. Someone amazing called, I think her name was Imogen. It might be Imogen or Isabel. I will tell you next week when I show it. She was on the tray herself. She made a huge tray on a carpet because she wanted to put herself on there, which is brilliant, a brilliant idea. But as many things begin with I on a tray as possible, but they all have to be different. You can't have iPhone, another iPhone, another iPhone, another iPhone, another iPhone, just as many iPhones as you can find. It's got to be lots of different I things. You can't just have 900 ice cubes. The ice cubes would count as 1 for ice. I'm giving away too many answers right now, so I'm going to go. I've been Mr. Harris. You haven't been Mr. Harris. I hope you've learned lots today. Look after yourselves, and hopefully I'll be back tomorrow with a bit more of a presentation and that will be for the transition. I'll also be here at 12 o'clock for the students who are learning about plotting quadratics. That's the secondary one today. We're plotting quadratics. We did plotting linear graphs on Monday. We're plotting some quadratics in about an hour and a half. I am going to go and help a very tearful baby and help a possibly very tired mummy. So, speak to you soon. Bye-bye. Okay, I can still hear some people have said that we're watching out Patrick with people. I think I've been answering the questions as people have been going along, and people have been saying, I understand now. Nathan's asked a question. Can you have an infinite number of decimal places after decimal points, Sophie? Yes, technically, although I don't fancy being the person who's to write down infinite number of decimal places. Let me just pause the music, because the music is probably stopping you hearing me very well. Sophie, you can go on for infinite, but you wouldn't want to write them. If it's 4-digit, would it be 0.7260 or 0.0? So they're both two different decimals. So 72.6, Harry, that 72.6 would be 0.7260, but 0.07 would only be 7.3% or 7.26%, because the first two decimals tell you which percentage it is. So it's the first two. So in your two examples, 0.07 would be one, and 0.72 would be one. Do we start on the 1st of January? Let's start on today's date. Look for today's date on the Corbett Maths. So find today's date, and then it'll be one for today, and then you try the different levels. So that's useful. Yeah. You can hear me because I'm still explaining things to people. Okay, I'm now going to go.